we ready? Oh, we're ready. We're live. Cool. So I hope you had some heated discussions with the Spring guys during the break and feeling a little bit warm now.
Thanks for coming back. You know, by the way, it was a complete lie when we said we have 600 books to give away. But thanks for coming.
Well, we have lots of content, very technical content we're going to share, though, which is going to keep you warm.
Well, thanks. There's plenty of people who say that our talk is good, so, you know, that's good.
Make sure you rate it very highly, though.
Spring buff at 9 p.m., Antonio. It's for you. Don't be shy. Ooh.
Oh, you don't want him in the Spring buff.
No, I would love to. Hey, you know, I use Spring on a day-to-day life anyway. And I was just saying to the guys, there's plenty of good things with Spring. Unfortunately, I won't be there. At 9 p.m., I won't be there. I would be with my lovely partner. Not you, Aaron, you know, just the other one, the female one, not you. Unfortunately,
that doesn't mean I'm not lovely, though.
Unfortunately, I won't be able to make it for the, you know, to the Spring buff. Again, you know, I mean, I'm independent. I don't work for Oracle, Red Hat, etc., etc. I use Spring extensively on a day-to-day basis, really. And I'm always a bit bitter because when I talk about Spring, because I think there are fantastic guys in the team, and if they would have joined earlier, world would be a better place.
Yeah, see, I completely agree with that sentiment in the sense that there is some fantastic amount of work that has gone in Spring, and many, many thanks to VMware, Pivotal, Interface 21. Java EE is here because of them. Absolutely. I mean, no doubts about that. I mean, unless they would have given us a kick in the butt, you know what? Go get your act together. Unless that simple book written by Rod Johnson, you know, Java EE would not be here. And this is a constant game. I mean, in this version of Java EE 7 platform, as a matter of fact, we picked up a lot of things from Ruby on Rails, Groovy on Grails. You know, wherever we found the good practices, we tried to inculcate them. And I don't see anything bad about it, because effectively we are learning and we're making the platform mature. Those are good, well-tested practices in that sense. So Spring, no doubt, is a fantastic program, as a programming model. People ask questions all the time, oh, is Java EE going to make deprecate Spring or vice versa? I don't think so. I mean, there is so much investment in Spring. You can use Spring for your legacy programs. Modern is good for Java EE in that sense, but I don't think that's going to happen.
And that goes with another question just comes after. NoSQL and big data support for Java EE 8. I would be the one voting no if it goes along. You know, again, NoSQL, big data. You know, what are we going to standardize in 3 years' time? There's a lot of things happening in the Eclipse link, in Hibernate. Those guys are trying to connect easily, map entities to document databases, and so on and so forth, and so on and so forth. That's I like this expression.
Yeah. It means et cetera, et cetera.
Et cetera, et cetera. Hopefully, no. You know, again, use Mongo, CouchDB, whatever you want. I hope Java EE 8 will not have that. Like, I was the one pushing back when Oracle said here at Devoxx 3 years ago as a keynote, we will push the cloud to Java EE 7. I was the one saying no. Well, no, I wasn't the only one. There was most of the people in the expert group was saying no, and Oracle was saying yes, and we won the battle because, you know, cloud, it's 2013. You know, a standard is something that will last, something that has been proved, etc., etc. So I really don't. I'm hoping we will not see any big data, no SQL, no SQL into Java EE 8.
See, the other thing to understand about NoSQL is, what is NoSQL? Is Mongo NoSQL? Okay. Is Couchbase NoSQL? Okay. Is Redis NoSQL? Is Hadoop NoSQL? And they all kind of sacrifice some asset property. They all conform to some base property, as a matter of fact, to be their own version of NoSQL. So with RDBMS, at least there was a common factor that they're all ACID. If they're all ACID, then that makes it much easier to kind of abstract a layer on top of it. That's not the case with no SQL. I mean, having said that, I think Thursday we are having a meetup with the Hibernate team here, trying to understand how the Hibernate OGM model could possibly evolve and take a look at that. And Eclipse Link also has done some great work over there. We're also trying to arrange a meetup with some of the Mongo folks to understand how they expect to see in Java EE. But as Antonio said, and I agree in the sense that we have brought up this topic multiple times within the Java EE expert group and always have come to the decision, it's still too early. I mean, the APIs are very different for those native drivers.
And last week there was a conference, I can't remember which one, and there was a tweet about a guy talking about big data. And he said, and it was quite funny, saying, big data is like teenager sex. Everybody talks about it. Everybody thinks the other one has done it. Nobody is really doing it. So let's give it a bit more time. It's not me. It's not me.
But I'm sure you got excited with that thought, though. Okay.
Let's come back to our stack.
Oh, expression language is so exciting.
Yep, expression language, because again, I was saying expression language historically has been bundled with JSP. The specification has been cut in two. Now expression language is living on its own as a 3.0. JSP, is doing his stuff, not much. And the idea when you take part of the specification out, like interceptors, transaction, or expression language, is you can give it back to everybody. That's exactly what we're trying to do. Expression language is not only for JSF, but it can be used everywhere. And in fact, it's used in bin validation for the messaging. So we have a new API. There's a bunch of APIs. The main one is the expression language processor. As you can see, it's just a class. You create an instance of it, and then you evaluate an expression. So here, A equals 1, 2, A1 equals 2. You can write that in your JSF pages, but anywhere in the Java EE space. And the expression language guy went a little bit further. They talked with the Java SE8 guys, and they brought lambdas on board. So you will have to wait a few extra months to use lambdas on Java SE8, except if you use the early versions. But you can already use it now with expression language in EE7. So and again, I'm saying EE7, but most of the specifications, most of the EE specs can be used in SE. So the previous slide will run on SE.
Right. Yeah, the point I wanted to mention over there is, so you can use lambdas today, not just on JDK 8 because it hasn't been released, but yes, it is available, for example, on the open JDK builds, which is where you can try. All right, Java server faces. Now,
wait. Who does JSF?
Oh.
Because it's always this controversy, everybody hates it.
Pretty much 60% of the room raise their hand
yeah,
right here.
Yeah.
And okay, you know what? If you those people can raise your hand again, once again, please. And how many of you love doing JSF?
Oh, bummer. We lost a few.
Come on, guys.
Yeah.
Okay, well, I'm glad your corporate is pushing you to do JSF because that's part of Java EE.
And a lot of people complain about that, and once in a while we have, why do you put user interface in Java EE? And again, Java EE should be a complete stack, doing everything. So at the moment we have JSPs that we are slightly dropping, JSF which is changing quite a lot. We need a UI spec in the EE ecosystem. I don't have a point of view on that because I hate web interfaces, and so I'm not a web guy, a UI guy, and I don't know anything about JavaScript and Angular and stuff like that. I just know that with JSF I can write pretty fancy UIs quite quickly for my customers. But no, I don't have a...
Yeah, and there are, I think, some really neat toolkits available as well. For example, prime faces, I've used it a couple of times on a Java 1 keynote. Rich faces recently has started releasing those fancy HTML5 friendly toolkits. So I think to me, the power of JSF comes from the fact that it is so tightly integrated with the rest of the Java EE programming model. Now, JSF, just like other Java EE technologies, is a pretty mature technology. In Java EE 6, we did JSF 2.0. One of the big things over there was how we kind of deprecated JSP as sort of the modeling part of MVC. Don't write your model in a JSP because you can do it. Now, what we did in JSF 2.0 is we use XHTML and CSS as the modeling part of it, basically taking the facelets specification, allowing you to write a view, I'm sorry, not the model, but the view part of it, take the view and write it using XHTML and CSS. But that was sort of one part of the work. Now, in JSF 2.2, we took that concept further, where we said, hey, you can do a pluggable look and feel, but that's not truly pluggable. What if you want to create a flow, for example, wherein you're doing a credit card, sort of a shopping cart page, where you're entering the shopping cart details, then you're entering the credit card details, and the address, and then the confirmation page, and then click on OK. And there are a bunch of backing beans behind it. What if you want to bundle all of that together and make it as a reusable flow? Now, this concept is not new, by the way. This is what I was talking about. We are borrowing and we are happily leveraging the concepts that have been tested very well. So Apache Faces, Oracle EDF already has these concepts. Now it's the idea of taking it and standardizing it, baking it into the platform itself.
And Spring Webflow, which
Spring
is
Webflow.
a very
exactly.
nice stack.
Yeah. Yeah. Now here, for example, in my jar file, and this is just a jar file in my webinif lib, I could say source main web app. I could have or well, in this case, for example, I'm having in my web app directory itself, each flow is uniquely identified by a directory. So in my main web app itself, I could have a flow. In this case, I'm calling it flow1. The entry point to that flow is the same XHTML file as the directory name. So flow1, flow1.xhtml. Then, of course, if I click around, then I can say how my navigation is in the flow is going to go through. In flow2, I could also declaratively define what my entry point is going to be. So this file, if not named as flow2, I can explicitly define how my entry point is going to look like. And that way I can define my flows over here. So the idea is flow2 directory or flow1 directory, I can zip it up as a jar, give it to somebody else, and they will have a same flow functionality that can be incorporated into their application. Not only that, because it's loaded through class loader, if you provide it using a mechanism that all your web applications have access to. So for example, a class or a library path, which is available to all the applications in your application server. You can drop it in there and then access it from your application. Along with Faces Flow, what also comes is a new scope, which is called as a flow scope. So basically what you have the ability is tie the instance of, or tie the life cycle of that bean to a flow. So if you are in a bean, then the bean is, if you are in a scope, I'm sorry, if you're in a flow, then your bean is active. If you're not in a flow, then your bean is passive. So this is what is used for your flow local storage that you can easily use. Now I talked about, for example, in the previous slide, how you can do declarative definition of flow over here in flow2-flow.xml. You can also do programmatic declaration of flow as well by using the annotation called as @flowDefinition. So here, programmatically, you define what the flow is going to look like. If you click on a button, should I stay in the flow, get out of the flow, what parameters I can pass back and forth between the flow. This is going to be a demo. This is going to be a demo, actually.
Oh, and something is the flow scoped is implemented as a CDI scope.
That is correct.
Again, you know, the transactional scope in JTA uses CDI, and JSF uses CDI.
So once again, these samples, as I was talking about, they're all accessible on the GitHub repository. I have a few flows sample here. So let me pick up a flows mix sample. What that means is I'm using flows that are declared programmatically and declaratively as well. Now I've tried, well, I build these samples using GlassFish, so that's what I'm using right now. But I've tried most of these samples, and they work very well on Wildfly as well. And just as a detour, if you guys are interested, tomorrow morning, tomorrow pretty much all day, I'm running a hacker garden. And as part of that hacker garden, the goal is to create unit tests for these samples. So I think that's the best way, in my opinion, to learn the technology. So I would say join us in that hacker garden. Antonio might be able to spend some time as well. We can create unit tests. We can actually have a lot more intimate conversations around Wildfly, GlassFish, and their specific issues. Bless you. Okay. Now, think about the flow as I was talking about. Let's say you are in a main page, and you can see we're both very graphically challenged in that sense. But you know what? If you're searching for something, do you prefer a Yahoo-style page or a Google-style page? So I think you kind of get the point here. So I'm outside a flow here. Now I'm giving you a graphical warning. The next page is going to be very bright. Safe for work, very bright. So I'm outside a flow here. Now if I want to get into a flow, I can say enter flow 1. Okay, well, it gives you the idea, that's what the flow looks like. So when I get into a flow here, in the flow, I could have a flow scoped bean. And using an expression language, I can actually get the value of the flow scope bean. I have also expression which tells me whether I'm in a flow or not in a flow. Then I can click on the next button and go to the next page in the flow. I can save some flow scoped values here. Click on next. And then the flow scope value is displayed nicely over here. From one flow, I can go to another flow. And JSF allows arbitrary nesting of flows. So you can keep going into the stack and then keep popping out of the stack as well. Nesting is completely dependent upon your application. Now from here, I can go to enter flow 2. One more warning. Oh, I'm sorry. It's been waking you up.
You are a CSS master.
Isn't it?
I would not be able to do that.
Yeah. Well, I guess this could be one of the things that we can fix in the hacker garden tomorrow.
Pink.
So here you can see that from one flow, I could pass parameters to the other flow. It kind of gives you the ability to pass those values back and forth between the flows. Then I can go to the next flow, next page in the flow. I can store a different value here. This is again a completely different value. From there, I can go back to flow 1. So that way, you can keep going back and forth. And if need be, you can say, you know what, oh, that home button didn't work. That's not good. Oh, let's try again. But now it worked. OK, never mind. So the point being, you can define your flows programmatically or declaratively, go back and forth between the flows, pass parameters, have EL expressions, store the values for you.
Go back to your browser. For those of you who know Spring Webflow and so on and so forth, no, I said it again. You can see in the URL you have a flow ID. So that's how JSF knows in which flow. So it generates a flow ID like SimFlow, Webflow, Spring Webflow, etc., etc.
So on and so forth. One of the good points too, actually, I'm glad you mentioned that, because one of the good points here is, think about in a browser, if you have opened an Amazon session, let's say you're doing some shopping cart stuff over there. You open up another tab in the same browser, you see the same shopping cart over there. With Flow, you can actually maintain 2 separate shopping carts in 2 separate tabs. That's sort of the capability that Flow brings with you, because it's assigned to not a browser session, but to that combination of the tab and the browser as well. Yeah, I was talking about how you can have local flow storage, using hash flow scope. This is my EL expression here, and how we have extended the overall expression language within the JSF land itself to be able to access whether you are in a flow or not in a flow. Another thing that we added to JSF 2.2 is called as a resource library contract. As I was talking about earlier in JSF 2.0, we had this pluggable viewing layer with XHTML and CSS. Now, which is good because you can truly have your model or view in XHTML and CSS. Your model and controller sitting at the back end could be completely Java EE components. But what's missing really is, what if I want to make that pluggable look and feel truly pluggable? Well, here you go. So in this case, I can have just indexblue.xhtml. Well, let's see the code again, actually. I hope it's not that bright this time.
So that can be useful. I work for customers who build websites for other customers. And, well, they create a white website, and then they put the style sheet of different customers so they can have the look and feel of their own customers. And that's a nice way of doing it with JSF.
Right. So here, for example, I'm saying just a red header. I can say go to blue contract, then the header becomes blue. I can say go to red contract, and then the header becomes red. Well, it's just a simple red and blue, but if you look at the actual code behind this, in contracts library, for example, in web pages, I just have these two files, index blue and index red. In webinf, what I have is a lib. In the lib, I have my contracts library impl, which is where my exactly XHTML and CSS are bundled. If you want to take a look at my contracts library impl, which is generated right here, so this is where both my contracts are available. My CSS, my XML, my XHTML. All I need is this file called as javax faces contract.xml. And you can see this is just a blank placeholder file marking this directory that it's holding a contract. If you have that, and that's about it. You could defining a contract here. Once again, you can put this jar file in a directory accessible to all of your applications, and then they can refer to it, and then you have your custom look and feel. And last but not the least feature, I think this is a lot more explainable again using code as well. Last but not the least feature in JSF is pass-through attributes. Now, as part of HTML5, we have added, HTML5 has added new attributes called as type attributes or data star attributes. But the way JSF works is it says, if you are giving me a tag, I need to have a UI component in behind it, and I need to have a corresponding HTML render kit behind it that's going to render the element, which is basically going to generate the HTML, send it to the client side, and then the user agent, typically my browser, which is going to render it. If you put an element over there which I don't understand, I'm going to ignore it. As simple as that. Okay? So let's see what the behavior is before and after.
The pass-through attribute really is the JSF guys didn't want to create all these attributes with new name, hashtags and namespaces. So it was just the idea of letting things go through. So no matter if you do HTML 5, 6, 7, with this technique, you say to the JSF render, just path this attribute, do not compile it on the server side.
Correct. So if I look at, before Java EE 7, for example, and in here, I just want to enter my favorite color. So I literally have to type the word red. Okay? Let's look at the generated source code here. the key element that you're looking for over here is the input element, which says type text name equals this. Okay, I mean, it's some JSF random generated variable. If I look at my XHTML page,
is it big enough? It looked a bit blurry for me. No, is that fine? At the back, is it okay, the code?
Always been blurry?
No, they're all talking to the Spring guys. They're not listening.
So if I look at index before.xhtml, here I said h:\input text value is this, type equals color, but it does not recognize type equals color because there is no corresponding UI component or render kit that is available to render it. Okay? If I go back and I say with Java EE 7, this time it shows up actually as the operating system specific color palette. Let's take a look at the code first of all. So I still have input name. This time I actually have type equals color element over there and how that element got generated. Now I still have type equals color, but this time it's saying P:. Now P is a random prefix I've chosen. You could choose whatever prefix you like. But the important part is this is a new namespace that is defined by the JSF specification. And what it says is any attribute that you're going to put in this namespace, I'm not going to touch any processing out of it. I'm just going to pass it as it is to the user agent. And then the user agent, which if hopefully is HTML5 compliant, will render it accordingly. So, I mean, we're just showing you one use case here with type attributes. You can use with any data store attributes or anything that you like. Oh, yeah. We also have finally, a file upload in JSF. Feels so powerful.
So why did it take so long? Well, because JSF relies on servlet, on the servlet specification, but it relies on the previous version always. So JSF 2.2, the latest and greatest, relies on servlet 3.0 and not in 3.1. They always have a version late, that's by design. So only servlet 3 integrated upload. So that's why JSF now integrates with servlet 3. And so with one line of code, you can upload a file. I actually have another talk that I'm not giving here, where I do a lot of hacking, and with just one line of code, you select a file on your hard drive, uploaded it, and that's it. So
yeah,
quite handy.
The important part to realize is you get access to the part in your backend bean, but you are still responsible for serializing it or whatever you want to do with it, because it doesn't serialize the file for you by itself.
So the part here is from the servlet package. JAX-RS 2.0. Oh, again, that was the animation showing line by line. Sorry, it's a PDF.
I can do it like this.
JAX-RS 1.1 was brilliant to expose REST services, but didn't have anything to consume them. So we were using curl and other APIs. Now there's a client API. So JAX-RS exposes REST services, and now you can consume it. And again, if you look at the code, it uses the good old Fluent API. So you have the client builder, it creates a client, and with this client now, you're gonna create an invocation to your REST endpoint. So if you look at the bottom, the very last line, you said client builder new client, okay, that returns a client, dot target, that returns a web target, dot requests, so that gives you an invocation, all this is new, and then you do a dot get, dot post, dot put, and that returns a response, and you can even cheat. You see on the get, you can pass the MIME type. So you can say here when I do a get, I want a string, so that returns a string. So in only one line of code, you can hit a REST endpoint, and it will return you, in this case, a string. So new API. You can also do an asynchronous client call because there's an async method. And again, this will not return you a response, but will return you a future, like Aaron explained a few hours ago. The same mechanism applies here. Once you get a future, you can either get or cancel or something like that. So that's how you do an asynchronous call on the client side, but you can also do it on the server side. So as you can see here, I have a REST endpoint, and the method async get gets asynchronous response as a parameter, and that's the one you will resume. That's typically when things could have been better in the EE landscape, because here we're actually creating a new thread, and an hour ago we told you do not create threads. So things still can be improved. Specs have their life cycle, and sometimes they join on time, sometimes not. So here they are using threads while you can use the concurrency utilities. Hopefully things will get better in the future.
Yeah, this is particularly one use case where I wasn't very happy with the programming model, and I agree with Antonio. There's definitely scope for improvement because of the late kind of work around JSR 236. Hopefully in Java EE 8 will improve this programming model.
Message filters. We were talking about that in the WebSocket. The same thing happens in JAX-RS. You have an incoming or outgoing request and response, and you want to intercept them and filter the code from one side or to the other side. So if you go to the next slide, you will see, oops, here I'm creating a filter, logging filter. It implements a client request filter. There's 4 filters: client, server, request or response. So I implement an interface. I have to implement the method filter. And now I have the context of this call. I can intercept this call and do something with this interception. In this case, I print the method and the URI being intercepted. And we also have entity interceptors. So filters, you just intercept a call. Entity interceptors, don't get me wrong, this is not JPA entities. An entity in JAX-RS, it's basically the body. So what you do here is you intercept the content of the body and do something with it, as a reader or a writer. So if you go to the next slide, what we'll do here is we create an interceptor that is going to zip the content of your HTTP call. So we implement writer interceptor. We have to implement this method called around write to. So again, like around invoke, etc. Around write to, and we get the entity of the message and we zip it. And proceed. So again, like the interceptors, when we intercept the call, take the entity, transform it, we have to proceed and let the container proceed with the other calls. JSON P. So with JAX-RS comes, XML, so on and so forth, and JSON. Everybody talks about JSON. In the XML space, we have JAX-P, processing XML, and JAX-B, the binding XML. Now with Java EE 7, we have the JSON-P, we process JSON, and it looks like we will have a JSON-B in EE8, so a spec that will do the binding between an object and JSON. So now we just have a very low-level API, a bit like JAX-P, a very low-level API to build JSON objects and to process JSON objects. You know, again, we like the fluent API style. So here I create a JSON object just by adding objects to the graph. So there's a JSON facade. I create an object builder, and with this builder, I will add nodes to my document and will end up with a JSON object. So that's one way of building that. There's also a JSON parser. So when you read a JSON document, like JAX-P and SAX, you'll get events. So each time you read a JSON document, and each time you hit a node, you will get an event. You will get a JSON parser event, and you go next, 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 next. So it's a very low-level API, and the JSON B, so the binding in JSON, will use the JSON P to do all the parsing and the building.
Now, one thing to realize is that the use cases in that sense is like if you want to read the entire JSON structure in the memory, that's when you use the object model API. The eventing API is where you want to be a lot more efficient about, no, I don't want to read, I mean, it's a big JSON structure. I want to care about that specific key and their values and so on. And that's what the use case is.
And if you have a big chunk of JSON, you can process this in a batch way.
There you go. And so let's talk about batch then. All right. Well, this is one after 15 years, I believe, that Spring finally decided, you know what, it's time to give something back after taking for so many years. So this is JSR 352, where Spring guys were kind of active, and they were actually very active. And as a matter of fact, a lot of the concepts, most of the concepts, I would rather say, are coming from Spring. So if you do Spring batch, these concepts would look very, very familiar. As a matter of fact, somebody actually pointed to me once I blogged about, about a year and a half ago or so, that this is from the Spring batch spec. Anyway, to explain the basic concept of batch, in terms of batch, what we have is a batch is a job. Each job can have one or more steps, or multiple steps. Each step, could be a chunk or a batchlet. Chunk is a primary processing style, and that's what I'm going to talk about. In case of chunk, think about the use case where you are reading from a CSV file. Let's say you have multiple cineplexes like these. At the end of the week or end of the day, you're getting a report from each one of those in a CSV file. You want to take the CSV file, you want to process, validate the record basically, and you want to write it. Now, you may not want to write for every read. That may not be very efficient for you. So what you do is you read, you process, and then you aggregate for writing. And once you have reached a certain number of items, then you say, I got 10 items now I can write it to the database. And that's what this is showing. So you execute a step, you read an item, you process an item, and then you give it for aggregation. Read, process, and then eventually, let's say you have read a few items, then you give it for writing. And then eventually you exit. So let's see actual code on this one. So let's see actual code on this one, because this slide is ugly.
So when you are familiar, if you are familiar a bit with Spring Batch and other batch frameworks, we have, well, I think we'll talk about it, but you have a job repository that knows everything about the jobs, and each job is made of several steps. So it's, you'll have an API to know what's happening, which job is in which state, which step are running.
Now, the entry point to any job is called as a job specification language. And in case of Java EE 7, that's defined as XML. And so that's why it's called as job XML. So in this case, for example, you can see I have a job. Job has a logical identifier. And this job has one step. Typically, your job will have many more steps. This is just a canonical job. Step, again, has an identifier. This step happens to be of the type chunk. In this chunk, I have a reader, where I'm going to read the item. I have a processor, where I'm going to process the just read item. And then I have a writer where I'm going to aggregate and eventually write to the output stream. And what I'm saying is item count 3. What that means is I'm going to read and process 3 items and then write it to the database. So let's take a look at what my reader, processor, and writer look like. In terms of reader, I'm extending the abstract item reader here. I just have an open method, which is where I initialize my streams from where I'm going to read the data. In this case, I just have the CSV file bundled with my var file. This could be your JAX-RS endpoint. This could be your JMS. This could be your database. This could be a stream from somewhere else. But this is where essentially you initialize. And then I have a read item method where I'm just dumb reading the item. I'm just reading it, and I'm not processing at all. Just read the item, hold on to it. Well, effectively, you pass it on to the processor. And the processor is where all the processing happens, which is basically my validation. I just have one method here. I'm implementing item processor. That gives me one method, process item. The item just read comes over here as a method parameter. Then I'm doing some validation here. All I'm saying is I want a strict validation of the date. Let's say if it has a date or it has a numeric amount. So you want to do some validation over there. If there is an exception, I return null. Basically, I'm saying, okay, this item is not valid. Do not aggregate it for actual writing. And if the item is valid, then I'm creating a person. Now, if I look at person here, this is a JPA entity. So the part that I want to highlight here is the incoming parameter is a string. The outgoing parameter from the processor is a JPA entity. There could be 2 completely different data models. You have truly transformed your incoming to outbound here. And then finally, if I look at my item writer, I have a write items method, which takes a list. And this is where the runtime, this is where my aggregation automatically happens. You just need to put all the components together in terms of reader, processor, and writer in the job XML, and the batch runtime automatically takes care of aggregation for you. The important part to understand is, as part of my job XML, the entire job, or entire step, or entire chunk actually rather, each chunk is run within a container managed transaction. So the read, process, aggregate, and write, all of that goes in one transaction automatically. And then when the next chunk starts, the next transaction automatically starts. That's container managed. There is no control. You don't have any control over it because container controls it.
Yeah, Aaron, that goes into a question that just appeared. Will batch work outside the container?
That is true, actually. The batch actually does work out. Batch is one API, JSR 352, that actually does work out of the container. Now, the batch 352 or JSR 352 reference implementation was built by IBM. That can be used outside the container. And then in Wildfly, we also have JBarrett, and that can also be used outside the container as well. So yeah, what we would like to see is if somebody blogs about it and send us a pointer. The other missing piece from here is I got my job XML, reader, processor, writer. How do I actually trigger the job? Well, that's where my very handy servlet comes in. So in my servlet, all I have is batch runtime. As Antonio was explaining, there's a job operator or a batch job repository. From there, I say, give me the job operator. To the job operator, I say, start the job. And this is basically saying my job, which is essentially the name of my job XML. All I say is pass the name, and then it kickstarts the job. And the job can, stop, the job can fail, the job can terminate for different reasons. There are no standard tools available right now, but the API provides all the mechanism using which you can build your own standard tools on top of it. GlassFish, for example, has a sort of a web-based admin console where it gives you the status of the current jobs. Hopefully when JBus EAP comes out, we'll have a lot more fancier tool as well. And other vendors should be able to provide similar tools too. Now that was the chunk processing style. Batchlet processing style is more like, well, in the chunk style, we were doing item-oriented processing. where you are taking an item, operating upon it till it kind of gets written to the output stream. Batchlet is more like a task-oriented processing style. I just want to do a task, like send an email or upload a file or do something. And that's why the item-oriented processing style is a lot more preferred in batch API. Just like Spring, we also have listeners. The listeners can be configured at different levels. You can configure at job level, step level, read level, writer level, all those different levels. You can configure those listeners, which are basically your extension points on what you want to do before and after that particular component has executed. I also want to quickly talk about how we have corresponding interfaces and abstract classes. Abstract classes provide a common implementation of those interfaces. Very standard design pattern, but just a convenience for you that you extend from the abstract class and get going with the default implementation. So here, for example, I'm showing you a simple sample of how my job listener would look like. There's a before job and an after job. So you can do things before and after jobs. So let's say logging. You're doing your cross-cutting concerns right here itself. Another powerful feature of the batch API, which I'm going to show a code for.
Spring Batch is now part of Java EE. Yes, but the spec lead was IBM. Just remember that.
Yeah, I think that's a big difference, in the sense that Spring Batch is well from Spring. This JSR 352 is the work of the JCP, which is actually backed by Oracle, Red Hat, Apache, IBM, and all those guys. So that to me is like, as a financial planners, we talk about, well, not we, but people tell us, you should diversify your investment, and that is sort of the lesson to me. Another important thought process, these days we carry cell phones which are like 4 core, and we talk about how do we make this batch jobs a lot more efficient. So for example, in this I'm defining my simple chunk processing style, reader, processor, and writer. In addition to the reader, I'm passing 2 properties, start and end. And the goal over there is, let's say I'm reading like 10 million records or even 1 million records, and I have a 4-core machine. I want to split up the job of reading across my 4 cores. So what I do is, declaratively, I'm defining a partition. I'm saying 2 partitions. I know it's going to be a 2-core machine. So in the 2 partition, I specify the start and the end value. Those values automatically get injected into my reader, and my reader knows where to read it and stop reading from. So that's kind of a cool thing. Well, I'm doing this declaratively here, but most of the time you don't know what kind of capability would be existing on your deployment machine. So you can do this programmatically as well. So both those capabilities exist. Some other concepts that exist as part of batch is how you can execute the components as a flow, wherein you're saying, oh, this step and this step must execute before you move on to the next step. So I want to make sure I wait for step 1 and step 2 to work with each other. Even within flow, you can define how do you want, in which order do you want the steps to execute. So you can define sort of a workflow, for example, in your job XML on how you want these things to execute. And you can also do a concurrent execution of flows as well. All of that, as I was talking about, was done more like declaratively. And this slide basically shows how you can do that programmatically as well. So I think that's one thing that the batch JSR is pretty good at, in terms of providing a declarative way of it and a programmatic way of it.
We will be finishing in 10 minutes, the timer. On this side, we will be finishing 5 minutes because we only have a few emails. I was reading Java Mail, so a few slides. So we will have a 5 minutes question. So if you want to shout at us tweets, do it, and we will answer at the end. It's nearly over. So the good thing with Java EE is we took the data source definition in EE6, saying with one annotation you create a data source, and we did that for JMS, as we showed you, but also for Java mail. So this is a way to create a mail session. Again, instead of going to your app server and doing commands or specific XML, you can do that with one annotation. Same thing for JCA. So a connector, you can now, with one annotation, create a connection definition. So we've updated all the little specs that haven't been updated for quite a long time, like Java Mail and JCA, to have this kind of new feature.
As you can see, there is a lot more focus on a POJO-driven approach. You take a POJO, sprinkle an annotation on it, and let the container do the hard work for you, wherein you don't have to rely upon a container-specific tool. For example, in case of GlassFish, you don't want to say AS admin create this resource and where to create it. I mean, just make a simpler, lower bar to enter the platform.
And at a platform level, EE7, well, EE is there to take all the specifications and tell them how they should work all together. And at the platform level, we did, let's have a default data source. Let's have a default JMS factory. So now, within your code, you can have a data source and just do, inject it. You don't know which one is being used. It's the default one. In JBoss, it's a HSQLDB. In GlassFish, it's a H2 or something like that, or Derby. So the default one is just a default JNDI name that will work. So again, talking about portability, you just inject a data source. You do not give it a JNDI name, and it will work in all the app servers. You're using the default one. And same thing for the JMS factory, and as we saw for the mail session, etc., etc. Same thing for the concurrency utilities, as Aaron said. And something new, that doesn't make much sense, but it's like that. All the namespaces have been updated. So from Java EE7, you will not see sun on the XML.
On the XML, yeah, I'm glad you clarified that.
Sun is over. Now the new namespace use xmlns.jcp.org.
Well, the good thing is this namespace is independent of Oracle too. If Oracle gets acquired by somebody else, this namespace can still live.
Yep. Oh, you were saying that someone is going to buy Oracle.
Well, I don't know, but nobody thought Sun. Anybody would buy Sun. Oh.
Yeah, then you can buy our books.
Yeah, we're both authors. We've both written books on Java EE7, and I think these books provide you good details.
Actually, it's the first time in the EE history that a specification is out, and there's about 6 or 7 books on EE7. The best one being mine.
All right, I'll give it to you.
Thanks.
So a couple of quick pointers I want to give. On Wednesday, Antonio and I are giving a hands-on lab. So if we got to kind of itch your scratch a little bit, scratch your itch a little bit, whatever that is, come to that hands-on lab. We'll be doing a lot more hands-on development over there, showing you complete hands-on experience of building an end-to-end application. Tomorrow, we have the Java EE7 Hacker Garden, where we will run all of these samples on Wildfly and convert into unit tests. So that way you'll get to learn these technologies. And since I'm there the whole day, we can have a lot more conversations on what do we expect from the technology and other platform. Fire away the questions.
Well, first you can clap. Second, you can start leaving. We are all adults here, so if you're bored, you can leave. And for the rest who are staying, we have 6 minutes left. Let's answer some unanswered questions. One is, when Java EE will take care about clustering? It's quite funny, but J2EE was created in '99, and everybody was doing clustering and failover and round robin, etc. Nowhere in the specification you will find the noun cluster. Java EE doesn't know about cluster. This is an implementation specific thing.
That is actually an application server feature on how clustering is done and things like that. So there's nothing in the specification that talks about clustering.
Will it be specified in EE8? No. EE9? Oof. 10? What we're thinking for EE8, and again it's not sure, we just talked about that at Java 1, is to have a spec, maybe the good old JSR 88 that we dumped, a specification that will allow you to deploy a web app, you know, start a node, shut down, see the status, you know, some basic API that will give you provisioning, but in one node. You know, we don't talk about cluster, and we won't be talking about cluster, I think, ever in the spec.
Some other concepts that we have been thinking about is, you know, we hinted through the presentation, JSON binding, JSR 107, which is caching, you know, which missed out as part of Java E7. Configuration JSR is another that we are thinking about. So there are different things as the Java E expert group has been thinking about in terms of the future definition. Oracle has announced a project Avatar. So if something comes around the TSA line, where, you know, a JAX-RS backend with the TSA, you know, TSA backend with a more HTML5 friendly front end. So we'll see, you know, what really comes through the expert group.
Another question, what happens when you use the default data source, queue, and mail session in different applications? So this slide, maybe, you know, we went a bit quick on that, but the JNDI name, the default JNDI name, yeah, is Java column comp. So the namespace is related to the component. So if you deploy several web apps in one single app server, it's the data source of the component. So it will be a different one, okay? Each time you deploy a web app with a default one, the namespace goes only to the component itself. So the others, you know, there's no interaction between the data sources. Thanks to the speakers. Well, thanks to the attendees.
Thanks to the attendees.
What else do we have? Someone was saying, well, two people were saying, what about the API for batch? Why don't we use generics? Because you pass an object.
Yeah, so I can handle that. Well, if you recognize, about 3 months before the actual release, there were generics in the batch API. And we really, I mean, I really loved it because that kind of shows me cleanly what my inbound and the outbound objects is, or list of person and getting in string and getting out person. But because of some last minute glitches, you know, we could not clean up the programming model. The generics were literally pulled out at the very last minute. So hopefully the future version of batch JSR, and if you care about it, I think that's one of the important parts I would like to mention. If you really care about any particular feature, Java E7 was run in an absolutely transparent way. You know, anybody could join the expert group alias, participate in the discussion. We did adopt a JSR effort where 20 different jerks from around the world participated in it. So if you care about any particular issue, I would say go to the JIRA of that spec, file an issue. Say, you know what, I care about JSR 352. I would like a Java API instead of the job XML to define my job. So file an issue. I mean, if you don't raise the voice, we will not hear it.
That was actually one question. XML declaration for batch is really heavy. You know, we were showing you flows in JSF. You can use XML or an API. You can, you know, we have several examples in Java EE where you have both, but unfortunately we have plenty of examples that we only have one. So, well, as Aaron said, things will improve. We have 1 minute left, no questions. I think you can clap again.